So here we are in the Packet Tracer Skills Integration Challenge for Networking Academy Chapter 8. And some of you are well on your way to finishing this, but I do think some others are stumped perhaps, or at least struggling. So I wanted to provide a few strategies to get you going on the right path. So we see that there are some instructions, and I'll try to get these so that they fit on the screen and we can see them. But one thing that I always do, if I do not already have a PDF or Microsoft Word document of the instructions, and sometimes even if I do, I will, cut and paste the entire instruction material into my own Word document. And so here I have the empty addressing chart. I've used the Windows snipping tool to actually take the topology and put that into my Word document along with the instructions. And you'll see that I've added some additional resource material at the end of that document that's going to help us with the addressing part of the problem. So let's look at the requirements. First, we need to configure the initial settings on the branch A and branch B routers. That I'm going to leave up to you, because that is really chapter 3, 4, 5 skills, and that should be old hat by now. So let's move on to the second requirement, which is instructing us that LAN A1 is using a /23 subnet of 172.20.16.0. And we are, of course, going to assign some specific router interface and end device IP addresses from that subnet. And then for the next subnet, LAN A2, we are going to assign from what they say is the next available subnet. But in addition to that, we are going to use perhaps a different address mask, because we want to conserve our IP addresses. So we're going to choose that mask to give us a maximum of 250 hosts. So we'll come back to that in just a moment. The LAN B, B1 and B2 are going to be using some IP version 6 addresses. And in this case, we are going to use 2001:DB8:FADE:00FF in a /64 world for B1, and then assigning the next available subnet to B2. A few more requirements. We're going to assign the first IP address to the router interfaces. That's pretty common in our work so far with the Cisco Networking Academy. We are going to use in the IPv4 networks the last IPv4 address for the PCs, so the last usable host address for the PCs. And for the IP version 6, we are going to assign the 16th IPv6 address to Again, for router descriptions, we'll leave that up to you, and also remind you that the link local address in the IPv6 world is used as the default gateway address. And of course, verifying the connectivity will be left to you as well. So let us start by getting you on the right road with calculating the correct IP version 4 and IP version 6 addresses so that you can complete this wonderful chart on the top. So let's start with the G00 interface on LAN A1. We are going to use this 172.20.16.0/23 subnet, and we are given the direction that the first usable address in that scheme is to be used for the router interface. So let's fill that in right now. We have 172.20.16.1, and we have a /23 network. So that means that the first 23 address bits are used for the network, and the final 9 bits are used to address the host. So therefore, the first 23 mask bits are 1s, and the last 9 are 0. That translates to a subnet mask of 255.255.254 and 0. And just to make those stand out a bit, I'll just put my inclusions in red. Okay. Now, the G01 interface, or in other words, the LAN A2, okay, so over here, that's the one that's going to be accommodating 250 hosts, and it is instructed that we use the next available subnet for that LAN A2. So what does that mean to us? Well, that first subnet was in a /23 world. We'll say that the imaginary dividing line was there at the 23rd position, which means that we could count from 1, which is what we gave our router interface, okay, and all the way up to the broadcast address, which would have been all 1s. Of course, when all the host addresses are 1, that is the broadcast address. So 1 fewer than that would be represented in this fashion. So that final, address we could convert back to, decimal to be able to know the address range for our usable addresses. So PC A1 on its network interface is in this same address mask, because it is in LAN A1, and it is going to be using the last available address in that range. Now, how did we get this number? It is nearly this calculation. Right? So if I take this bit, which is 16, and the one bit, that changes to 17, and then here we have 254, which is 128 plus 64 plus 32, 16, 8, 4, and 2. So we have the answer for PCA1, and the default gateway, of course, is the IP address of that G00 interface, because if we're sitting at PC1 and we're looking out for a way to access beyond our local network, it would be that G00 interface of the router that we need to contact. PCA2, now we have to look at the specifications for finding the next available subnet. So that is for LAN A2. So the next available subnet is going to be how we count directly after 11111111191. Okay? So that is going to be flipping this bit to 1, and that would be the next number if we were just counting in binary. But to conserve addresses, we've been asked to not be wasteful. So you can accommodate 250 hosts with a /24. So we can actually take this imaginary line and move it over one position. And we'll be able to count between usable host addresses between 1 and 254. So that is much more efficient than using the /23 addressing. So in that world, we have a first usable host address that could be represented in binary in this fashion. If we fill in the rest of the network addresses, the bits, we can see that we have 18 in the third octet and 1 in the fourth octet. So we can represent that address in this fashion. And because it is now /24, we have 24 1 bits in binary, or in dotted decimal, 255.255.255.0. So again, I will put my newly entered addresses in red. Now let's take a look at the IP version 6 world. What is being said about that? Well, LAN B1 is using this subnet, and the router interface is using the first usable address. So copy that in for starters, and the first usable address will just be address number 1. That was pretty straightforward. Now, the second LAN B1, is instructed to use the next available subnet. So we have to understand how we represent subnets in an IP version 6 world. And that's where this little diagram at the bottom of the page comes into play. IPv6 represents addresses with 128 binary bits, where the natural segmentation is that the first 64 bits represent the prefix or network, and the last 64 bits represent the interface ID or host addressing. But that first 64 is broken up into 48 bits for what's called the global routing prefix, and then the next 16 is the subnet ID. So if we look at an IPv6 address written in hexadecimal format, we can see that it is this portion right here that is representing the subnet ID. So if 00FF represents the subnet ID for LAN B1, and we want to use the next subnet for the B2, that means we just merely need to add 1 to this portion. Well, you can perhaps see right off what needs to be done, or think back to binary. F means that there are all ones in the binary representation. So if I add 1 to this number, we would end up with 0, 1, 0, 0. Because in the same way down here in the binary world that we had all ones, and then when we counted to the next number, we turned everything to 0, and the next bit to the left flipped to 1, the same thing would happen. So we have, for the G01 interface, this hexadecimal representation. The admonition on the numbering for the PCs is to use the 16th, I believe it's for IPv6 networks, assign the 16th IPv6 address to the PCs. So rather than 1, remember we're counting in hexadecimal, not in decimal. So the 16th is represented by 10, right? You can count from 0 to 15, so that's 16 separate addresses with the first bit position, and then 10 represents 16. Okay, so I actually copied that one into the wrong subnet. So here we have the subnet B2 and B1 would be like this. We recall that it is the link local addresses that are used for the default gateway. And that is the same link local address for both of those. And the network interface card address for CCNA2 is going to be the last countable address in the .18.1 LAN. So that is going to be 18.254, and that same address mask. And the default gateway is going to be the closest router interface to break out of this local LAN into the outside world, which would be the branch A router's G01 interface. Or 172.20.18.1. So hopefully those instructions make a little more sense to you now, and that you can use these tools to be successful with the remainder of the challenge.